Hey guys, Miss Miklos here, and this is our Chapter 2 review video. And I'm going to go through a bunch of different questions that are going to be similar to things you guys need to know for the test. So the first thing that I want to just briefly discuss is determining if relations are functions. So the first way that we'll do this is if we see ordered pairs. So if we look at number 1 here, we learned if we have ordered pairs, I need to make sure that for each input, there's exactly one output. That is our definition of a function. So in this case, I need to see, do the x values repeat? In this case, no, they don't. Okay, each is a different x value. So we would definitely say, yes, this is a function. Now, on one like number 2, when something is graphed for us, this is when we are going to use our vertical line test. So I'm going to go straight across, and we know it is a function if at every point I'm only touching one particular point. Okay, so every x value only has one point on it. And I gave us this one on purpose because if we're right here, some of you might be thinking, no, that's not a function. However, I want to point out a point is a solution, an open circle, not a solution. So this is actually not an output. So as I go across, every single input has only one output. So for number 2, we would say, yes, that is a function. Lastly, number 3, if I'm going straight across, right away I'm hitting more than one point. Okay, and I'm just going to draw an actual vertical line so we can see that. I'm hitting a point there and a point here. So we would definitely say, no, this is not a function. So I'm going to say no. Now, our other test was with mapping, and I know we talked about that a decent amount in class, but I really want to make sure that you guys know these two particular ways to test if something is a function. Next thing I want to talk about is evaluating functions, and I chose the hardest example that we will see, and that is our wonderful, exciting piecewise function. So, if we look at number 4, it says f of -2. I know that this -2 is our input, and that represents our x value. Now, what makes this more difficult in a piecewise function is I need to figure out which of these domains does it fit into? Okay, so is -2 less than 3 or is it greater than or equal to 3? And I'm going to call this first one domain number 1 and the second one domain number 2 just so it's easy for us to kind of think about. And if we look, -2 is definitely less than 3. So that means I could care less about this equation right here. I can cross it out if I want for that problem. I only care about the top one because this is the domain that fits. So if I'm doing f of -2, I would do 2 times -2 squared plus 3 times -2 minus 1. So I have 2 times 4 minus 6 minus 1, 8 minus 6 minus 1. And when I work from left to right, I end up getting 1 as our output. When I look at our second one here, f of 3, this time this fits in domain number 2 because 3 is greater than or equal to 3. I don't care about that first function then, and I'm just going to substitute f of 3 into our second one, which would be 2 times 3 plus 5. 6 plus 5 is 11. So that would be our output. So just a reminder that our input is being substituted in for x. When we have a piecewise, I just need to determine which domain it goes into. And if we think about it, it would make sense that we only have one answer, one output, because we're saying this is a function. That's why it has function notation. Okay? If this was not a function, then it would be okay if we got 2 different answers. But the whole definition of a function is that for every input, we only have one output. Okay, I'm moving ahead here to graphing linear equations. And I chose one in standard form because I often find that that is more difficult for us. Now keep in mind, I don't care what method you use. If you love slope-intercept form, go for it. I'm going to use standard form though. Remember, in standard form, our slope is the opposite of a over b. So I'm going to do the opposite of 2 over negative 1, which is positive 2. My y-intercept is c over b, so that would be 2 over negative 1, or negative 2. Okay, we know a y-intercept is an ordered pair of 0, negative 2, because an y-intercept always means the x value is 0. An x-intercept means that the y value is 0. So I'm going to go down here to negative 2, so that's 0, negative 2. A slope of 2 tells me I can go up 2 and to the right 1, or we could have gone down 2 and to the left 1. So I'm going to go up 2 and to the right 1. Now I'm going to go ahead and draw my line. It is very important we are using arrows to show that it continues in both directions. And I only need to have 2 points drawn. Just a reminder on our test, I need to see our slope, I need to see our y-intercept. So let's take it one step further. Let's graph the inequality now. So once again, this is standard form. So my slope here would be the opposite of 1 over 2, which is negative 1/2. My y-intercept would be 4 over 2, which is 2. Or we could think of that as an ordered pair of 0, 2. So this time, when I begin, I'm going to begin at 0, 2, and a slope of negative 1/2 here tells me I'm going to go down 1 to the right 2, or I could go up 1 and to the left 2. So I'm going to go down 1 to the down 1 to the right 2. And when I draw my line, I need to decide, should my line be solid or dashed? And that is all dependent on this inequality symbol. This inequality symbol is telling me just less than, so that means that the values on this line are not solutions. So it is important that I draw a dashed line to represent that these are not solutions. It's like it is a boundary. Now we need to figure out where the solutions actually are. I'm plugging in my favorite ordered pair 0, 0, which is on this side. If 0, 0 makes a true statement, I'm shading everything here. If 0, 0 does not work, I'm shading up top. So let's do it. 0 plus 2 times 0 is less than 4. 0 is less than 4. And we know, of course, yes, that is true. So I'm going to do all my shading on that side. Okay, these are all the solutions to this particular inequality. Once again, I'm showing my slope, I'm showing my y-intercept. Okay, so on this particular problem, we are going to go ahead and deal with this piecewise function. So, first thing is I'm going to go ahead and figure out what direction each of these two particular parts of the piecewise function are heading. So I know that this first line is to the right and including 0 because of this inequality symbol. I know this second portion is to the left of 0 because of this inequality symbol. So now I'm just going to look at this first line. So I'm going to say line 1, and that is f of x, or y, equals 2x plus 1. So I know my slope is 2, and I need to figure out what is the value at 0. The reason why I'm choosing 0 is because that is the x value where it jumps from one part of the function to the other. So I'm going to say f of 0 equals 2 times 0 plus 1. So I get an ordered pair of 0, 1. So I'm going to begin by putting an ordered pair at 0, 1. And I know that this point is going to be closed. And the reason why it's closed is because it's including. I'm going to the right. So a slope of 2 tells me to go up 2 and to the right 1. And then I'm going to go ahead and draw a nice line connecting those. Now, my second line is y equals negative 1/3 x. So my slope is negative 1/3. And when I put in 0 again, negative 1/3 times 0 is 0. So I have an ordered pair of 0, 0. This ordered pair has to be open because of the inequality symbol. I know it's not equal to. A slope of negative 1/3, I know that means that it should be decreasing from left to right. So I'm actually going to go up 1 and to the right, and to the left 3. And I'm going to draw my line. Now, just to check, this first line has a positive slope. So from left to right, is this increasing? Yes. So that matches what a positive slope should look like. Our second line from left to right, is this decreasing because of this negative slope? Yes. Final thing I might do is just double check our vertical line test. If we go straight across at every single point, I'm only touching one point here. This x value only has one output or one y value because this right here is my only answer. Here's another example of a piecewise function, and I wanted to go through this one because for some reason this tends to throw us off. So there's really 4 parts, but I know this first part is just saying y equals -3. So our ordered pairs would be -4, -3, and -2, -3. And I'm getting those values from these particular x values right here and right here. So I'm going to go ahead and graph a point at -4, -3. And this point should be closed because of the inequality symbol. And I'm also putting a point at -2, -3, which would be open. And then I'm going to connect those with a solid line. Okay, -4, -3 was closed because of this inequality symbol. -2, -3 is open because of this inequality symbol. My second line right here is just y equals 1. So my ordered pairs are going to be -2, 1, and 1, 1. And I'm going to connect those with a horizontal line. And I'm getting these x values from these 2 endpoints, and this is telling me everything between those values is on that line. My third line is y equals 2, so at 1, 2, and at 5, 2, I'm going to put my ordered pairs and draw my line. Now, if I am using a vertical line test, at every single point there's only one point on my line, so this matches our vertical line test. It passes that, so I know that it is a function. Next question is one of our absolute values. So we know that we have 4 characteristics we need to figure out. First is our vertex. Our vertex is always the opposite of our number here, and then our k value. So that would be -1, -3. Next, I need to figure out, is this going up, is it going down? So it's based on our a value, which is -2. Since that is a negative value, we're going to say it opens down. If it was positive, it would be opening up. Next, we figure out, is it fatty, skinny, or normal? And this one is actually skinny because of this -2. Remember, it's skinny if the absolute value is greater than 1. It's fatty if we have a fatty fraction, so that means the absolute value is less than 1. And it's normal if the absolute value is equal to 1. Finally, my line of symmetry or axis of symmetry is always x equals whatever the x value in our vertex is. So I'm going to go ahead and put a point at -1, -3. Down and skinny, I'm going to use this to help me sketch. A slope of -2 normally tells me I'm going down 2 and to the right 1. Now, since this is symmetric, I'm going to do the same thing to the left and go down 2 to the right 1. And then I'm going to go ahead and sketch my line of symmetry. And that's telling myself that I understand if I fold on that line, it would be a reflection of itself. Greatest integer functions. So I'm going to start with x minus 3, and the greatest integer of x minus 3. Now remember, our first column should always be our input. Our final column is our output. Our middle columns help us to figure out our output. So I'm going to start off by putting in 0, 0 minus 3 is negative 3. The greatest integer less than or equal to negative 3 is negative 3. If I put in 0.5, I get negative 2.5. When I round that down, I get negative 3. If I put in 0.9, I would get negative 2.1, which rounded down is negative 3. So what that is telling me is that everything between 0 and negative 9 has an output of negative 3. So I'm going to go ahead and put a point at 0, negative 3. And I'm not quite sure where this changes or where our jump happens. Okay, I'm thinking it's going to be pretty far. In fact, let's go ahead and try 1. 1 minus 3 is negative 2. The greatest integer less than or equal to negative 2 is negative 2. So I'm going to draw an open circle at 1, negative 3, and that's telling me that leading up to this point, all our outputs are on this line. As soon as I hit negative 3, it jumps up, and I can start to kind of see a pattern here where it's going to change every single step. So from 0 to 1, it's going to be an output of negative 3. From 1 to 2, it's going to be an output of negative 2. From 2 to 3, it's going to be an output of negative 1. I can keep going in either direction, but this is all I really need to be my final answer. Okay, so writing the equation of the line, just so you guys know, I don't care how you write it. I personally think that using point slope form is the easiest method here, but we could also use standard form or use slope intercept. It doesn't matter. Since we have a point and a slope though, I think point slope is the way to go. So just a reminder, that's y minus y sub 1 equals m times x minus x sub 1. So I know that y sub 1 and x sub 1 represent this ordered pair, and m represents the slope. So I have y plus 3, and the reason why I'm saying plus 3 is because minus negative 3 makes a positive, equals 2 times x minus 1. So I'm going to go ahead and distribute that 2, so I have 2x minus 2. When I subtract 3, I get y equals 2x minus 5. If you guys did this in standard form, the acceptable equations would either be negative 2x plus y equals negative 5, or we could also write this as 2x minus y equals 5. On your test, I would give you full credit for either of those three options. Now we're adding in parallel and perpendicular. Remember, the perpendicular slope is the opposite reciprocal. If it's parallel, it's just the same. So I'm just going through the one that I personally think is tougher. So the first thing I need to do is figure out what is the slope of 2x plus y equals 5. I'm using standard form. If you wanted to use slope intercept and isolate y, that would be fine. Okay, I know the slope for standard form is the opposite of a over b, so I get negative 2. So I need to think what slope is perpendicular. So I'm going to say m sub perpendicular. And I know perpendicular is the opposite reciprocal. The opposite would make it positive, and the reciprocal of 2 is 1/2. So if I'm doing y minus y sub 1 equals m times x minus x sub 1, I have y plus 2 equals 1/2 times x minus 1. Y plus 2 equals 1/2 x minus 1/2. When I'm subtracting 2 from both sides, I get y equals 1/2 x. Negative 1/2 minus 2 would be negative 5/2. If you guys had written this in standard form, you would have gotten 2y minus x equals negative 5, or x minus 2y equals positive 5. Okay, so, and we probably would switch the order of these two, but I would accept that. Okay, now, I definitely think it's the easiest to just leave it like this. So, Big thing here, perpendicular, opposite reciprocal. If it's parallel, it means the same. Here's a hint. I would expect one like this on our test. And it can seem really tricky. However, aren't x-intercepts and y-intercepts just ordered pairs? So, our x-intercept would be 3, 0, and the y-intercept would be 0, 3. So, some things I would have to do with this, our slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Yes, the y's are on top for all of you that struggled on that slope quiz. And I would do 3 minus 0 over 0 minus 3, which gives me 3 over negative 3 or negative 1. So now I'm going to go ahead and I can use either ordered pair. I'm going to go ahead and just use this first one. So I'm going to do y minus 0 equals negative 1 times x minus 3. So y equals negative x plus 3. This one's always a tricky one as well, just because I think we overthink it. I need to think what type of line has a slope of 0, and that is when we have y equal to a constant. Just a reminder, if our slope is no slope or if it's undefined, that's when we have x equal to a constant. So in this case, honestly, there's not that much work for me to do. And to be completely honest, in this case, if I wanted to, I could use point slope form and I would get the right answer. But I think what is easier, as soon as I know it's a horizontal line, I'm going to write y equals, and I need to look and see what is the y value here, and that would be negative 4. So y equals negative 4 would be our answer. Now, if this had said through 2, negative 4, and no slope, then our answer would have been x equals 2. So we definitely need to pay attention what kind of line has a slope of 0, what kind of line has no slope. Okay, so for number 16, we need to take this function and write the equation. So I'm going to start by saying f of x equals, and the first thing I'm going to figure out is our domain. So our first one to the left here, I can see that is to the left of 2 because this x value here is 2. So I'm going to write x is less than 2. My second portion here is to the right of 2. So I'm going to go ahead and write x is greater than or equal to 2. The reason why I use greater than or equal to is because it was closed. Now we know we need to find a slope, we need to find a y-intercept. So this line, it looks like my slope is going down 1 and to the right 2. So I'm going to write negative 1/2 x. And I'm going to pause here, and from left to right, this is decreasing, so it makes sense that my slope is negative. I also need to figure out what is my y-intercept, and I can clearly see right here at negative 3, it crosses the y-axis, so I'm going to go ahead and put negative 1/2 x minus 3. Our second part of the graph, we can tell it has a negative slope as well. In fact, it looks like it's going down 2 and to the right 1, so I'm going to say negative 2x. And it is decreasing from left to right, so that makes sense. Now, this one, it doesn't cross the x-axis, so the y-axis. So there's a few things we can do. We could use point slope form to find the y-intercept, or I could continue my line going up 2 to the right 1, up 2 to the right 1, and I can see that it crosses at 5. Okay, so whatever is easiest for you, okay, remember point slope is y minus y sub 1 equals m times x minus x sub 1. I don't care which way you do it. I just want you guys to feel confident in whatever method you choose. Okay, so on this absolute value problem, yes, I know it's absolute value because we have a v. I need to go ahead and write the equation. Okay, so I know it's going to be the absolute value of x plus or minus something plus or minus something. So first thing I notice is that my vertex is at negative 4, negative 2. we said normally we get this x value by taking the opposite of whatever's in here. So since it says minus 4, I'm going to write plus 4. Our y value of our vertex we normally get from our k, or whatever we add outside, so I'm going to put minus 2. So we use our vertex to figure out what these two values represent. The final thing we need to figure out is our a value, so I'm going to look at our slope. So here it looks like it's going up 2 to the right 1, so that would be a slope of positive 2. So this would be the equation to our function. Okay, now it makes sense that this is positive because our v is going up. If this value is negative, we know our v would be opening down. Hopefully this quick review, or not so quick, helped you on kind of the overview of the chapter. Make sure you are asking questions, coming in for help if you need additional help on any of these concepts. Study, 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 and do your best on the test. And don't forget your responsive writing.